Assalamu alaikum class, how are you? I'm Amuna Sayyed, your science teacher. This is your science book, Science 1, and I'm going to present lesson number 1 and welcome to the week 2 of online session. So here is unit 8, energy, and the topics under discussion are energy and forms of energy. You can see different forms of energy and sun is the main source. Look, so powerful. Here are some learning objectives. So in this lesson, we will be covering energy and different forms of energy. But first, I have a warm-up activity for you. So who is going to tell me how do your families use energy? Well, you have 30 seconds. Just think about it and tell me. Let's see the answer. Yes, we are using energy in the form of light, in the form of heat, air conditioning, cooking water, heating them, and we also using energy when we are using car. So these are some of the very basic examples of how our families and we are using energy. Let's see what is energy. Energy is the ability to do work. Okay? So it is not easy to say that what energy is. This may seem rather strange because all around us we can see, hear, and feel the effects of energy. We burnt it as wood, coal, oil, or gas. We eat it in our food and we use it as electricity to run our TV, laptops, and computer. So we use energy to kick a ball or to fly a kite as well. To keep us warm using it as a heat during winter. We use it to light our homes and we listen it to as sound. We feel its effects when we drop something on our toes. So we can use the effects of energy to do the things we want to do. So this is uh, some of the examples to understand that energy is very important in our daily lives. They cannot be destroyed and they cannot be created, rather they can be passed from one object to another and the total amount of energy remains the same. Energy occurs in many forms as we have just discussed that we if we heard the sound of this trumpet or we can um, hear any form of sound energy, so it is also energy. Here you can see a boy playing a trumpet, a radio, a ringing bell. So all of them are producing sound energy. Further, as I've just told you that we are also using energy when we use our car. So anything that is related to movement, they are having kinetic energy. Here you can see the example. He's striking a hammer, he's racing a car. There is a pendulum that is continuously moving. And when we strike a ball, then it's also occurs some sort of movement which results in kinetic energy. So the plate of food contains stored energy, stored chemical energy. So whatever you have just in your breakfast, it means you have some energy in your body and it was in the form of chemical energy and then our body will further process it and will utilize the glucose reserves to produce oxygen out of it and for uh, the food of cells. The basic constituent of the cell will be accomplished when the body cells will gain this energy. Okay. Further, the light from this candle is a form of energy. Simply, the light from this candle that is coming out, it is in the form of heat energy and the light energy. So, if we are sitting in a lighting room, it means we are also enjoying light energy. So, these are some of the very common examples you can observe in our daily real life examples. So, these are real life examples just to make you understand what energy is and how much it is important for us. This kettle uses electrical energy to heat water. Maybe some of you have made your tea in this kettle and you were using electrical energy, and when you use microwave oven to heat up your food, it means you are using some electrical energy as well. So look, these are so many examples coming from our daily life. Here a very important example, some of the energy in the water tumbling over the Turbila Dam is used to provide hydroelectric power. So hydroelectric power means the energy that we are getting from water. So in hydroelectric power station, we use water energy to drive the shaft of generator and ultimately they produce electricity. Here you can see the different forms of energy, that is the heat energy, light energy, sound energy, potential energy, nuclear energy, electrical energy, chemical energy, kinetic energy. But so these are also examples of some heat energy, solar energy, chemical energy, electrical energy, and mechanical energy. So this picture I pasted it over here just to make it easy for you to understand the one basic examples of every sort of energy. Okay, but remember the main source of energy is the sun. Look, he's so happy. Heat energy. So if we talk about the heat energy, it really the effect of movement energy of molecules. Have you ever observed when we are going to make a tea, when we put some water in a pan and when we start heating it, we can see the molecules move faster. Okay, so why this is so? Because the heat energy is creating some sort of energy and movement in the particles, and heat flows between things that have different temperatures. So the water, it was having low temperature, so the heat energy moved from the energy of high concentration towards low concentration. So it flows from the hotter things to the cooler things, and the hotter something is, the more energy it has. So heat can be used to do work. There can be many examples. Like I have just given you a real life examples you can observe daily in your kitchen. So this is matter, okay? So matter are basically made up of particles, and every particle is in a movement due to some sort of energy providing us in different forms. So here is an example of boiling water. As we increase the temperature, it means that kinetic energy or the movement of the molecules is also becoming greater and they will allow molecules to escape into the air. So as heat is added, the particles move faster. And when they start moving faster, the temperature goes up. And the rate of particles movement is directly proportional to the temperature. And the sources of heat energy can be the sun or any material that is burning. It can be wood, it can be candle wax or coal. Okay, let's jump into the next slide. So here is another example like when a coal fire burns, the chemical energy stored in the coal is changed into heat and light energy. Okay, so the heat escapes to warm the room. That is also a form of energy, that heat is escaping to warm up the room. Here you can see the coal. If you ever seen a fire area in our room or in our living room sometimes, so this is how the heat energy escapes and then they starting warming up our room. So same phenomena is taking place here, that heat will start moving from the area that is hotter towards the area that is cooler. So in this way, the whole room will get heat up after some time or so. So talking about the light energy, it's a form of energy that is carried by a light waves. Okay, so this is carried by the light waves, and anything that looks shiny, they gives off energy. And most of our light energy comes from the sun, as we have just discussed. That sun is the main source of energy. So other natural resources include stars, lightning, and fire. So here you can see the example of different light sources: star, sun, fire, candle. So these are some of the very basic real life examples you can observe in your nearby environment as well. So moving ahead, we humans also need energy to see plants, and the plants need energy to produce their food by the process of photosynthesis. And light is basically set out by burning fuels. When we burn fuel, we basically producing heat energy and light energy as well. And when electricity is passed through the light tubes and also through heating elements of electric fires and electric cookers, so they also producing electric energy and they are also using light energy. Lightning, if we can use or control lightning, then we can use or we can prove to be an extremely powerful source of energy if we have some proper plants or proper place where we can exploit or harness this lightning procedure. So this is very you can see a powerful source of energy. Coming towards the sound energy, like heat and light energy, sound also travels in the form of waves. So this is very important from the MCQ point of view, that you need to remember that which source of energy travels in the form of heat or waves or in the form of waves. So these are some very basic points that you need to remember for your examination point of view. So it is produced by the vibrating objects. Whenever you see some vibrating objects, it's producing some sort of ringing sound, which is basically a sound energy. And sound energy can be easily sensed with our ears. Okay? If we take the example when we speak, so the vocal cords in our voice box start beating up or they start vibrating. And due to the vibration of our thin membrane that are vocal cords, we produce a sound, and sound travels through anything except vacuum. Now, the reason why the sound can't travel through vacuum, because as the vibration of the particles reach your eardrum receives the vibrations which the brain then interprets as sound. But what happens in the vacuum of space, there are no or there are very few particles to vibrate. So the sound cannot travel through this medium due to the lack of or due to very little or very few particles present over here. So I hope you understand that why the sound cannot travel through vacuum. Here you can see the potential energy. Potential energy means the stored energy, and it is the energy that is something because of its position. Whenever you are talking about potential energy, means we are talking about something due to its position. Here you can see a boy is standing over here and he is throwing something and he is getting some height, some position. So it means it's having potential energy. So anything that is lifted above the ground is given more potential energy, and this sometimes called a gravitational potential energy. And here is also someone is standing over a building and he is holding a ball, I guess. Okay. So this sort of energy are basically the potential energy that is due to the position. So the amount of gravitational potential energy stored in a raised body, it depends upon its mass and how high above the ground it is and how much gravity is pulling on it. So you can take different examples and some of these are given here. Here you can also see when a boy is standing over here, it means he is standing at some height, and now here he is possessing potential energy. The moment he dives off, he is possessing kinetic energy. Okay. So the amount of energy, as I've just told you, the potential energy is directly proportional to the height and the mass and gravity. So think about this example, which we have greatest gravitational energy if we throw a stone. that is dropped onto your feet from a height of some 1 meter, okay, or a larger stone dropped from the same height, what would affect you will be feeling? Like what effect would dropping both stones onto your foot from a height of 3 meters have, or from the height of 1 meter have? So obviously the stone that has been thrown from the high height will be having more energy. Okay, so you can understand what I'm saying. Another type of potential energy is the energy that is stored in a squashed or stretched springs or stretched elastic rubber, and it is also called as elastic potential energy. So the energy in in the stretched string or springs, they are having elastic potential energy. So this sort of stretched elastic bands has potential energy, as someone is will find out if it's let go of one end of it, you will feel a great strike. This is due to the elastic potential energy that is stored in this object. So the talking about nuclear energy, which is the energy that is stored in the nucleus of every atom. So, as we have discussed in our previous lecture, that everything around us is matter, and matter is made up of atom, which is the smallest teeny tiny particle which cannot be further divided. So, nuclear energy is released when the atoms of heavy elements like uranium are split up into lighter elements, and this splitting up is called nuclear fission. And when these elements are combining together, they are doing a nuclear fusion reactions because they are fusing with each other. And again, a lot of energy is released, mainly in the form of heat. And nuclear fusion in the sun gives out huge quantities of heat and light energy, and some of which reaches the earth. And the energy from the nuclear fission and nuclear fusion can be used for different peaceful purposes, in producing electricity, or for military purposes in nuclear weapons, or to power nuclear submarines. Here you can see a nuclear power station which uses the energy that is produced when a heavy element like uranium splits up into lighter elements, as we have just discussed, and they produced heat energy. And then we use this sort of heat energy to produce a steam which will drive electrical generators. Okay, so this is also a power station, nuclear power station. Here is an example of electrical energy, which so today's world, like we are living in an age where we relies heavily on electrical energy, and we are using up it for lighting our homes and streets, to provide power for our factories and communication, entertainment, means all sort of these luxuries we are using, or we are um, uh, continuously in use of electrical energy. So all of our modern technologies also depends on technology such as mobile, telephones, your laptops, computers. They all are using electricity. So electrical energy basically consists of the electrical charges which travel through conductors or wires. Okay. And some of the electricity comes from the batteries or solar cells, but most from the generators. But most of them comes from the generators. Here you can see solar cells, and these are our streets, which are fully lightened, and they are using electrical energy. So generators don't make electricity from nothing. So what happens? They have to be driven by some outside source. Like if we talk about the steam turbines, what is giving power to steam turbines? The steam that powers a steam turbine is made by burning coal. Okay, so what happens that the burning coal, oil, or gas, or by using nuclear generators, so these all are driven up by the steam that is generated by the steam turbines. So in wind turbine uses the energy that comes from the moving air or wind. And while in hydroelectric power station, The generator is driven by water turbines. So here you can see water turbines and different sort of energies that are using up to produce electrical energy. So here is your assignment. You need to read Unit 8, page number 76 to 782 and learn and write question and answer number 1, 2, 3, 4, 5. That is on page 93. Here is the key. Okay. So this is your question number 1. You will draw 4 lines and you will put these headings nicely and you will write the stuff under these columns. This is question number 2, question number 3, 4, 5. Now let's wrap up today's lesson. So first of all, if we talk about the energy, so energy is the ability of the body to do work. And we are using different types of energies like heat energy, light energy, sound energy, potential energy, nuclear energy, electrical energy, chemical energy, and kinetic energy. And we have also discussed all these sort of energies in detail. I hope you understand the lecture and it will be easy for you to learn these things. Good luck. Thank you so much. Allah Hafiz.